Recording in progress. Hello, yes. Hello, a very good morning to everyone. Sorry, I got delayed by 5 minutes. Laptop actually hang हो गया था, but I hope all of you are able to hear me. Yes, बेटा सब लोग को मेरा आवाज आ रहा है? Can you all hear me? Okay, so let me share the whiteboard also and let's start the lecture. Okay, so let me just tell you what exactly we have done in our previous class. बेटा in the previous class अभी तक हम लोग जो स्टडी किया है, we have discussed about what is a moment of force. In our previous class हम लोग discuss किया है what is the moment of force. If a rigid body is rotating about an axis, then the force that is called a moment of force. And after that we had a discussion about a couple. When the two equal and opposite forces are acting, they're said to form a couple. After that, we have discussed about the angular momentum. The moment of a linear momentum, that is called an angular momentum. And after angular momentum, we have seen a relation between a torque and angular momentum. This is what we have seen. Can I get a quick reply? इधर तक किसी को कुछ डाउट है, कुछ कंफ्यूजन है in any of the topics, or everything is fine? Okay, that's great. That's great. I'm very happy to get a reply. All my students are replying. Everyone, almost everyone is replying in the chat box. सब बच्चे लोग reply करता है इधर तक. Okay. Now बेटा आज का अपना टारगेट क्या है? If I'll tell you the entire target for the 2 days lecture, आज हम लोग क्या करने वाला है? So in the one line I can tell you, we will going to complete the entire theory. आज हम लोग पूरा थियरी कंप्लीट करने वाला है ये चैप्टर का. अब ये थियरी कंप्लीशन में हम लोग क्या क्या स्टडी करने वाला है? So the very first topic we have to study is the equilibrium of a rigid body. When you say a rigid body is at a equilibrium, सबसे पहला topic. After that, we're going to study what is the center of gravity. Students, if you are able to recollect, already we had a discussion about a center of mass. Now we have to study about a center of gravity. After the center of gravity, we have to study a new topic which is called a moment of inertia. हम लोग है ना moment of inertia का study करेगा, and after the moment of inertia, the next topic it is a radius of gyration. What is called a radius of a gyration? And after the radius of a gyration, we're going to study theorems to find out a moment of inertia. That is a theorem of a perpendicular axis and the theorem of the parallel axis. And then we'll be looking at the motion of a rigid body. And after the motion of a rigid body, we shall look at the law of conservation of angular momentum. Law of conservation of angular momentum. And last May, small discussion about a rolling motion. This is what I have planned for the 2 days lecture. So I hope with all your permission, I can start. May I know if the permission is granted by you? क्या सब लोग सर को परमिशन दे रहा है कि I can start teaching? Students, sorry for the delay. I don't know what has happened. Laptop हो गया था, मैं कुछ नहीं कर सकता. Yes. Other students are not replying. I can see there are many students. मेरे बहुत सारा बच्चे लोग इधर है but reply नहीं कर रहा है. I can see Anushka is there, Sneha is there, right? कितना सारा बच्चे लोग है. Then Ashiti, Mayuri, Rushabh, Ayush, Devanshi, Sarthak, Akash, then Abde, Alicia, Parth. There are so many students I can see they are present, right? Okay. So with all your due permission, I'm starting now. What I'm starting the concept of the equilibrium. What is the meaning of the word equilibrium? But let us say that this is a body. ये कोई body है. This is the body. अभी ये body को हम लोग है ना कोई force apply किया. To this body, I am applying the force. Now the force is applied from this side. So what will happen if I'll apply the force from this side? Can somebody give the answer? अगर इसमें force apply करेगा तो जैसा मैं इधर से force apply करेगा, this body will start moving. Yes or no? Let us say that now another force is applied on this body. There is a one more force that is acting on this body, and the direction of this force is opposite. Not only the direction of this force is opposite, the magnitude of both forces are equal. So if the magnitude of the both forces are equal and their direction are opposite, I can say the body will not move. And this type of the condition we call as the equilibrium. Equilibrium मतलब balance करना, एक force दूसरे को balance कर रहा है. So if a number of forces are acting on the body, if the body doesn't move, then it is called a translational equilibrium. Similarly, बेटा अगर force का जगह पे torque लग रहा है, then the body will start rotating. So if a number of torques are acting such that the total torque is zero, then the body is said to be in the rotational equilibrium. So what is the condition for the translational equilibrium? The sum of all the forces should be equal to zero. And for the rotational equilibrium, the sum of all the torque should be equal to zero. So I can write like this way: equilibrium of a rigid body. For this equilibrium of a rigid body, I can say a rigid body और शॉर्टकट में लिख सकता हूं for translational equilibrium, a rigid body is said to be in the translational equilibrium if the sum of all the forces which are acting on this rigid body, this is equal to zero. Sum of all the forces which is acting on this rigid body, it is equal to zero. And if a body is said to be in the rotational equilibrium. Beta, a body is said to be in the rotational equilibrium if the sum of all the torques So ये भी लिखने का जरूरत नहीं है. No need to write I just to create a confusion. So I can say if sum of all the external forces acting on it is zero, and you can say A body is said to be in the rotational equilibrium if the sum of all the external torques that is acting on the body, it is equal to 0. So when the body is said to be in the translational equilibrium, when the sum of all the forces acting on the body is 0, and the body is said to be in the rotational equilibrium when the sum of all the torques are equal to 0. Now, student, if you are able to recollect, a torque is equal to 0. Correct. समझा सबको इधर तक? Now, once I have understood this, then we know already हम लोग study किया है the sum of external forces. What is the sum of external forces? The sum of external forces is the force is the rate of change of momentum. Right? Force is the rate of change of momentum. And we have discussed about the sum of the torque in the previous lecture. Torque का formula, it is a dl by dt. What is L? L is the angular momentum. बोलो yes or no? ये पढ़ा है ना हम लोग? So if I'm looking at the equation number 1 and 3, so my dear students, I can write from equation number 1 and 3. This left hand side is 0. So therefore, this dp by dt will be equal to 0. And if a dp by dt is equal to 0, I can say this p, it is equal to constant because the derivative of a constant is 0. Derivative of a constant is 0. Matlab, a body is said to be in the translational equilibrium when linear momentum is constant. Similarly, I can write from equation number 2 and 4. What I can write from 2 and 4? I can write from the equation number 2 and equation number 4. क्या लिख सकता है मैं? The sum of the external torque is equal to 0. So क्या होगा? This dl by dt, this will be equal to 0. And if this dl by dt is equal to 0, then this L will be equal to constant. L will be equal to constant. So, what I have understood is the body is said to be in the mechanical equilibrium, that is a translational and rotational. Therefore, or I can say therefore, a body is said to be in mechanical equilibrium What is the meaning of the total mechanical equilibrium? That is a translational and rotational. Translational and rotational. If both linear and and angular momentum does not change with time. Do not change with time. Okay. So I'm just making a full screen and I want everyone that first, if you can read this. So before you start writing, first I want you to read this. एक बार go through करो, उसके बाद में इसको जल्दी से complete करो. So can I get a quick reply? ये तो एकदम simple topic था. क्या ये सबको समझा? समझा 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 समझा. I got a first reply from Suhani. समझ गया समझ गया. If you are done, then you can just tell me. I can go to the next topic, that is the center of gravity. Thank you for compliments of handwriting. Thank you. अच्छा handwriting है. Okay. Thank you so much. Done, beta, done. All of you are done with this. Everyone is done. Just give me the reply if you are done. Other students, but are you done? Are you done? Done. Done. ठीक है, चलो आगे बढ़ते हैं अभी. The next one is, what is the center of gravity? Now you can just recollect. Already we have discussed about a center of a mass. Yes or no? Can somebody tell me what is the center of mass? Yes, very good. What is the center of mass? A center of mass, it is a point. It is a point on the rigid body where the entire mass is assumed to be concentrated, right? जो point पे body का पूरा mass concentrated होता है, that point we call as the center of mass. Similarly, जो point पे body का पूरा weight concentrated होता है, that point is called a center of gravity. So I can tell you in the one line, a point where the entire weight of a rigid body is concentrated, that is called a center of gravity. The center of gravity is denoted by CG. Again, I'm repeating. The point where the weight of the body may be supposed to concentrate it, or I can write like this way, the point where the weight of the rigid body is assumed to be concentrated is assumed to be concentrated is called center of gravity. Okay. So what is the center of gravity? A point where the weight of a rigid body is assumed to be concentrated. It is called a center of a gravity. So consider a rigid body. Let us say that there is a rigid body. So let us say that this is a rigid body, and this rigid body consists of a large number of the particles. A point mass, one point mass is m1. There is another point mass is m2, and so on. There is another point mass is mn. If these are the point masses, then each mass will going to experience a force. The mass m1 will going to experience a force, mass m2 will going to experience a force, and so on. Mass mn will going to experience a force, and the force ka formula is ma. So for the acceleration, this will be m1g downward direction, this will be m2g in the downward direction, and so on. This will be mng in the downward direction. So the forces which are acting, it will be m1g, m2g, and so on, mng. So I can say the total force, if I want to write this total force acting downwards, the total force that is acting downwards, and my dear students, the total force that is acting downwards, that is called a weight. This is called the weight. Now this weight will be m1 vector g plus m2 vector g plus and so on plus mn vector g. So I can say this weight W, it is equal to m1g plus m2g plus and so on mng. Or this weight W can be written as, this weight W will be m1 plus m2 plus and so on plus mn into g. Now, what is this m1, m2, and so on, mn? This m1, m2, and so on, mn, they are nothing but the total mass. So this is a total mass. Right. And what is the total mass? The total mass is m. So this weight W, it is written as a total mass m into g. So let us say the point where the total mass is acting is this point. If this is the point where the total mass is acting, which is W, it is equal to m into vector g. So this point we call as the center of gravity. एकदम simple सा concept है for the center of gravity. A very simple concept for the center of gravity. The center of gravity, it is nothing but the point where the entire weight of the body is assumed to be concentrated. Now, once I have done this concept of a center of gravity, now I can proceed ahead. So if you are done the concept of the center of gravity, let me proceed ahead and talk about what is the moment of inertia. Done. Samjha? If you are done, you can reply. Other students are also done. So I can proceed with the next topic, which is a moment of inertia. Yes, done. So before I'll tell you the moment of inertia, I'm just asking a few questions to you. You should give me the answer. Okay? Student, if we are in India, अगर हम लोग इंडिया में हैं, so for purchasing anything, we use a INR, Indian rupees. The moment suppose you go to USA, then to purchase the things, we use a dollar. So can I say this rupees and this dollar, they are equivalent to each other? Yes or no? In the India currency, there is a rupees. If you want to purchase anything, you must have a rupees. In the USA, you must have a dollar. Yes or no? रिप्लाई नहीं आ रहा, क्या हो गया? Yes. So, can I say the role played by the rupees in India, is it same as the role played by the dollar in USA? Yes or no? So dollar and role played बोला मैंने. I know that dollar का value is more. Role played का मतलब क्या होता है? To purchase anything, to purchase, let us say, a vegetable, a grocery, you need a dollar in USA and you need a rupees in India. It may happen that conversion factor may be a different. $1 is not equal to 1 rupee, that I know. But what I'm saying is they are equivalent. दोनों same role play कर रहा है. Similarly, whenever we talk about a linear motion or a translational motion, whenever we talk about a linear motion or we talk about a translational motion, the force is applied on the mass. The force is applied on the mass. हम लोग mass का बात करता है and we write the equation F equals ma. Now, my dear students, when we go to the rotational motion, जब भी हम लोग rotational motion में जाते हैं translational motion से, so वहां पे mass नहीं होता है. The quantity which played a role, that is called a moment of inertia. Moment of inertia. So what is the moment of inertia? बच्चे लोग ये moment of inertia है क्या? What is the moment of inertia? The moment of inertia is nothing but a equivalent of a mass in a translational motion. समझा क्या? What is the moment of inertia? The moment of inertia is the mass equivalent in the translational motion, or the role played by mass in the translational motion is same as the role played by moment of inertia in the rotational motion. जो role मास प्ले करता है ट्रांसलेशनल मोशन में. ट्रांसलेशनल मोशन में वी विल बी टॉकिंग अबाउट द मास. रोटेशनल मोशन विल बी टॉकिंग अबाउट द मोमेंट ऑफ इनर्शिया. क्या ये सब लोगों को समझ में आया क्या? Yes, very good. So the very first thing I can define a moment of inertia, I can say the quantity which plays the same role in the rotational motion as the mass does in the linear motion, that is known as the moment of inertia. फिर हम लोग मोमेंट ऑफ इनर्शिया फाइंड आउट कैसा करेगा, व्हाट इज द फॉर्मूला फॉर द मोमेंट ऑफ इनर्शिया, दैट विल बी लर्निंग आफ्टरवर्ड्स. So let's talk about the moment of inertia. Okay, so let me write. So I can write the quantity which plays the same role the quantity which plays the same role in rotational motion the quantity which plays the same role in the rotational motion as the mass does in the linear motion. As the mass does in the linear motion is known as moment of inertia. Is known as the moment of inertia. लिख के हो गया? Okay. Now, how this moment of inertia is defined? So let us say that there is a rigid body, that this is the rigid body, and this rigid body consists of a large number of point masses. The one point mass is m1, the another point mass is m2, and so on. The another point mass is mn. So if a rigid body consists of a large number of point masses, and this is the axis of rotation of a rigid body. This is the axis of rotation. This is the axis around which this rigid body is rotating. So if this is the axis of rotation of a rigid body, so if the distance of the mass m1 from the axis of rotation is r1, distance of the mass m2 from the axis of rotation is r2, distance of m3 from the axis of rotation is r3, and so on. If a distance of rn from the axis of rotation is rn, so if this distance is r1, this distance is r2, this distance is r3, so we say the moment of inertia is product of mass and the square of a distance. So the moment of inertia of a rigid body of a rigid body about a given axis is about a given axis of rotation is sum of the product of mass, product of masses and square of their square of perpendicular distance from axis of rotation. From axis of rotation. So if I'm looking at the large number of masses, then what is the moment of inertia? I can say the moment of inertia. So consider a rigid body, as I can see in the diagram. So consider a rigid body consists of n particles. So if a rigid body consists of n particles of masses, one mass is m1, another mass is m2, and so on. Another mass is mn at a distances. The one distance m1 ka distance is r1, m2 ka distance is r2, and so on. Mn ka distance is rn. Then what is the moment of inertia? So I can write the moment of inertia, which is denoted by I. It will be equal to m1 r1 ka square plus m2 r2 का square plus and so on. mn rn का square. Or I can write this moment of inertia I will be summation from I equal to 1 to n mi ri square. The moment of inertia of n particles. The rigid body is containing n particles, then the moment of inertia is nothing but it is a summation from I equal to 1 to n of mi ri ka square. So students, if you are done with this, then you can just tell me. I can proceed ahead with the next topic, a radius of gyration, and then the theorem of perpendicular and the parallel axis. Done? Okay. Now let's talk about what is a radius of gyration. And this radius of gyration, it is denoted by K, a very, very important concept. You need to pay a lot of attention to this about the radius of gyration. पहले मैं बताने का ट्राई कर रहा है. इसका मतलब क्या है? पहला डेफिनेशन देखो. क्या है इसका मतलब? इट इज डिफाइंड एज the distance from the axis of rotation. It is defined as the distance from axis of rotation it is defined as the distance from axis of rotation at which if whole mass of the body were supposed to be concentrated the moment of inertia would be same the moment of inertia would be same as with the actual distribution of mass as with the actual distribution of mass of the body in form of constituting particles. मतलब क्या है इसका? The meaning is, let us say that there is a rigid body and this rigid body is containing a large number of masses. One mass is m1, another mass is m2, another mass is mn. And this is the axis of rotation. This is the line. This is the axis of rotation. ठीक है? So this distance m1 का, let us say distance is r1. The distance of the particle m1, let us say, is r1. The distance of this mass m2 is, let us say, it is r2. The distance of the mass mn is, let us say, it is rn. So this is a distance r1, this is a distance r2, this is the distance rn. So how we can write the moment of inertia? The moment of inertia will be m1 r1 का square plus m2 r2 का square plus and so on plus mn rn का square. This is the moment of inertia. फिर क्या बोलता है? It is defined as the distance from the axis of rotation at which the whole mass of the body were supposed to be concentrated. मतलब क्या? Center of mass. अगर ये इसका हम लोग, if I can consider this as the center of mass, if this is a center of mass, so the distance from the center of mass to the axis of rotation, if it is taken as k, and the whole mass of the body is taken as m. So I can write this moment of inertia, it is equal to mk ka square. So in the very short trick, my students can remember in this way, beta the radius of gyration is nothing but a distance. कौन सा distance? A distance of the axis of rotation from the center of mass. The distance of the axis of rotation from the center of mass. समझा क्या सब लोगों को? What is the radius of gyration? The radius of gyration is nothing but, it is a distance of the axis of rotation. It is the distance of the axis of rotation from the center of mass. Okay. What is K? Beta, K is the radius of gyration. K is the notation for the radius of gyration. And what is the radius of gyration? As I said, the radius of gyration is nothing but it is a short trick में distance of the axis of rotation from center of mass. The distance of axis of rotation from the center of mass, that is known as the radius of gyration. समझा क्या? समझा क्या? ओके सब लोग समझा? Everyone has understood? सब लोग समझा? ओके फाइन. So let's complete this principal theorem of parallel and the perpendicular axis और उसके बाद ब्रेक लेंगे कि अभी ब्रेक लेंगे? You want the break right now or you'll be taking a break afterwards? Okay. Sahil has replied. ठीक है. So we'll be learning a theorem of a parallel axis and the perpendicular axis, and then after that we should take a break. Okay. So now, how we can find the moment of inertia of a different rigid body? There are derivations to determine the moment of inertia of a rigid body. Moment of inertia find out करने का derivations है और वो derivations में दो टाइप के theorems यूज होते हैं. The one is a theorem of a perpendicular axis and the another is a theorem of a parallel axis. So let me just tell you what is the theorem of a perpendicular axis and the parallel axis. क्या लिख दिया मैंने? So let me just tell you what is the theorem of a perpendicular axis and then what is the theorem of a parallel axis. पहले समझो ये theorem of perpendicular axis क्या है. The theorem of the perpendicular axis says that, let us say that we have a rigid body, that this is a rigid body. If a rigid body has a three mutually perpendicular axes, x, y, and z. So this is the center of a rigid body, and the three mutually perpendicular axes of this rigid body are x-axis, y-axis, and z-axis. So let me call this as the x-axis, this is the y-axis, and this is the z-axis. These three are the mutually perpendicular axes. Let's say the moment of inertia around the x-axis. If the body is rotating about the x-axis, then the moment of inertia it is Ix. If a body is rotating about the y-axis, then the moment of inertia is Iy. And if the body is rotating about the z-axis, then the moment of inertia is Iz. So these are the moment of inertia around the x-axis, y-axis, and z-axis. So what this theorem says that if you know any two moment of inertia, Ix, Iy, you can find Iz. If you know Ix, Iz, you can find Iy. And if you know Iz and Iy, you can find Ix. It means the moment of inertia around any axis, it is the sum of moment of inertia about the two remaining axes. So what this theorem says? This theorem says that the moment of inertia of a plane lamina, therefore, the moment of inertia of a plane lamina about an axis perpendicular, statement difficult लगता है, formula easy है, about an axis perpendicular to its plane, is equal to sum of moments of inertia is equal to sum of moments of inertia about two mutually perpendicular axes Okay. So the moment of inertia of a plane about an axis perpendicular to its plane is equal to the sum of moments of inertia about two mutually perpendicular axes. समझा ये समझा okay, fine, ठीक है. So I can see the time is 8:43. We shall meet exactly after 5 minutes. Don't leave this. Be there in the class only. Just take a rest. You can drink a water and all, and then we'll come back. Okay? So I'm muting myself for 5 minutes. Okay. So I think we are all back. Can I get a quick reply if you're all back after the break? जल्दी बोलो सब लोग आया क्या ब्रेक के बाद स्टूडेंट्स आर बी बैक आफ्टर द ब्रेक यस और नो ओके थैंक यू साहिल थैंक यू सो मच सो काइंड ऑफ यू ओके सो आज का मेन्यू साहिल ने दिया ना सैंडविच ये साहिल की तरफ से है ये साहिल ने सबको दिया है If you want to say thank you can say thank you to Sahil. नहीं मैं नहीं दे रहा आज का साहिल की तरफ से ओके चलो लेट्स कंटिन्यू आवर डिस्कशन नाउ लेट्स लुक एट व्हाट इज अ थियरम ऑफ अ parallel axis after the perpendicular axis we have to discuss about a theorem of a parallel axis. Let's discuss what is a theorem of a parallel axis. Okay, what is the theorem of the parallel axis says? First you understand, then we can write a statement. Statement में कुछ ज़्यादा importance नहीं है. We should know how to apply this. So let us say that there is a rigid body. That this is the rigid body. ठीक है. Now बेटा for this rigid body, अगर ये कोई rigid body है, then I want to determine the moment of inertia about this axis. This is the axis around which I want to determine the moment of inertia. Sorry. So I want to determine the moment of inertia about this axis, and this is I. So if I have to determine the moment of inertia about this axis, let us say this is a center C. This is a center C, and the line which is passing through the center and the line passing through the center the line passing through the center around this line if the moment of inertia is IC and its distance is h. Its distance is h. And m is the mass of this rigid body. Again, I'm repeating. You need to understand what exactly I'm saying. What I'm saying is, beta, if I have to determine the moment of inertia about any axis, and if I know the moment of inertia about an axis which is parallel to this and passing through the center, and I know its perpendicular distance h, then the moment of inertia about this axis I is the moment of inertia about the center plus the product of mass and the square of a perpendicular distance. मतलब अगर हम लोग को कोई भी एक्सिस के अराउंड अगर मोमेंट ऑफ इनर्शिया फाइंड आउट करना है एंड इफ आई नो वो एक्सिस का परपेंडिकुलर डिस्टेंस, रिजिड बॉडी का मास, moment of inertia about a line passing through the center, then you can take a sum of the moment of inertia passing through the center and the product of mass and the square of a perpendicular distance. So what it says, the moment of inertia of a rigid body moment of inertia of a rigid body about any axis, moment of inertia of a rigid body about any axis is equal to its moment of inertia is equal to its moment of inertia about a parallel axis through its center of mass plus the product of the mass of the body and square of the perpendicular distance between the two axes. ये स्टेटमेंट से ज्यादा इंपॉर्टेंट है हाउ टू अप्लाई दिस. जस्ट 1 minute. Sorry. So I hope you have understood. But what I was saying, that the moment of inertia about any axis which is parallel to the line passing through the center is the moment of inertia about the center and product of mass and its square of the perpendicular distance. Now I shall be giving you the list of the some moment of inertia of a rigid body. Okay, so I'll going to give you the moment of inertia of a some rigid body. It is up to you. If you want, you can take a short screen, or if you want, you can write it down. That is up to you. It is there in all books, but still I'm giving you. जल्दी कंप्लीट करो और रिप्लाई करो. So just complete this. You can take a short screen or you can write it down. No need to write. You can take a SS and then you can reply me done karke, so that I can proceed to the next topic, that is the motion of the rigid body, right? And a moment of inertia. How the moment of inertia played an important role in the motion of the rigid body, students. See to it that you are not leaving. Now, coming half an hour will be going up to be a very important. जब भी हम लोग अलग अलग formula देखेगा, what is the formula for the angular momentum, what is the formula for the kinetic energy, we're going to see what is the formula for the torque, and then the conservation of the linear angular momentum and its application. So see to it that you are not leaving. You can take a short screen, no need to write. Okay, done. Fine. So we can proceed ahead. All of you are done. Okay. So once we are done, now I can go ahead and I can discuss the things. Now the very first thing that I'll be talking about the motion of a rigid body and the moment of inertia. So let's talk about the motion of the rigid body and the moment of inertia. Okay. So let us say that this is the rigid body. This is the rigid body, and this rigid body is containing a large number of masses. One mass is M1, another mass is M2, M3, and so on, the mass Mn. Right? So consider a rigid body consisting of the masses M1, M2, M3, and so on, Mn, and this is the axis of rotation. This is the axis of rotation. Let the distance from the axis of rotation to the first point mass M1, it is R1. The second point mass M2, it is R2. The third point mass is R3 and so on Rn. जैसा हम लोग पहला लिखा था. So this is R1, this is R2, this is R3. I'm requesting to all dear students that जो लोग भी एक student शायद leave हो गया है, but if you can inform him that not to miss this part, not to miss this part. बिकॉज अभी हम लोग ना एंगुलर मोमेंटम का बात करने वाला है, काइनेटिक एनर्जी का बात करने वाला है, टॉर्क का बात करने वाला है. सो व्हाट आई एम सेइंग इज कंसीडर अ रिजिड बॉडी consisting of n particles of the masses M1, M2, and so on, Mn, at distances they are at a distances R1, R2, and so on, Rn. Right? As you can see from the axis of rotation. Now let's talk about the very first topic of this. What is the formula for the angular momentum? So I am talking about the formula for the angular momentum. Before I'll talk about the formula for the angular momentum, let me just tell you, already we know that if these are the masses, what is the moment of inertia? The moment of inertia, it is nothing but summation from I equal to 1 to n mi ri का square. Yes or no? ये सबको पता है. If there are large number of particles having the mass m1, m2 and so on mn, then this moment of inertia, और चाहे तो एक बार फॉर्मूला भी लिख देता हूं. Then how we write the moment of inertia? Then this moment of inertia I is m1 r1 का square plus m2 r2 का square plus and so on plus mn rn का square. This is the moment of inertia. And if this is the moment of inertia, my dear students, I can write this moment of inertia I will be summation from I equal to 1 to n of mi ri ka square. Let me call this as equation number 1. This is the equation number 1. Now, I want to write angular momentum in the form of moment of inertia. What is the notation of angular momentum? So we all know the notation for the angular momentum is L. L is the notation of the angular momentum. So this angular momentum L, that is the formula है ना, गीतेश ये formula है. Now what is this angular momentum L? This angular momentum L will be the angular momentum of the first particle, second particle, third particle, and so on, nth particle. Now, what is the angular momentum L1? This angular momentum L1, L का formula क्या? L is L का formula क्या है? PR. So this will be a P1 R1 plus P2 R2 plus and so on plus Pn Rn. मैं इधर लिख देता हूं. ये कहां से आया? Since L is P into R. बराबर. Now what is the formula of P? The formula of P is M into V. So if a formula of P is M into V, I can write this angular momentum L will be M1 V1 R1 plus M2 V2 R2 plus and so on plus Mn Vn Rn. Now what is the formula of V? Since the formula of V, it is R into omega. If the formula of V is R into omega, then I can write the formula of L will be M1. V1 का place पे R1 omega into R1 plus M2 V2 का place पे R2 omega into R2 plus and so on plus Mn Vn का place पे Rn omega into Rn. Now this will be M1 R1 square into omega plus M2 R2 square into omega plus and so on plus Mn Rn square into omega. So I can write this L will be M1 R1 का square plus M2 R2 का square plus and so on plus Mn Rn का square. Omega can be taken common. So this can be written as the summation from I equal to 1 to n of mi ri का square into omega. Now from equation number 1, What is the summation from I equal to 1 to n MIRI? This is a moment of inertia. So from equation number 1 and 2, I can write this angular momentum L will be I into omega. Angular momentum L is I into omega. Samjha? Don't write this. Wait, give me some time. After learning of this L equals I into omega, I can proceed ahead and I can talk about the kinetic energy. So the second one that we would like to study is a kinetic energy. Kinetic energy. So if I'm talking about the total kinetic energy, this total kinetic energy will be a kinetic energy of the first particle plus the kinetic energy of a second particle plus and so on, plus the kinetic energy of the nth particle. What is the kinetic energy of first particle? Half m1 v1 का square plus half m2 v2 का square plus and so on, half mn vn का square. Therefore, this kinetic energy will be half, I can take common, m1 v1 का place पे it is r1 square omega square plus m2 r2 square omega square plus and so on mn rn square omega square. Therefore, this kinetic energy will be 1 by 2 omega square, I can take common. So in the bracket, this will be m1 r1 square plus m2 r2 square plus and so on mn rn square, which can be written as half omega square summation from I equal to 1 to n of mi ri ka square. Now see this summation from I equal to 1 to n mi ri ka square. This is nothing but a moment of inertia I. So if this is the moment of inertia I can write a kinetic energy. Kinetic energy will be equal to half I into omega square. This will be half I into omega ka square. So we have done about the kinetic energy. इधर तक कुछ doubt है? I'm just making a full screen so that you can see. Don't try. Just give me 5-10 minutes, then you can write. कुछ doubt है? I can write beta angular momentum as I into omega, kinetic energy as I omega square. Can I get a quick reply from other students? Please, 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 please. जल्दी जल्दी रिप्लाई करो. Then I would like to write a torque. Okay. Once we have done this, right? Once we have the understanding of this, I can talk about a torque. So the third one, I can talk about the torque. So let's discuss about the torque. So the total torque can be written as the torque 1 plus the torque 2 plus and so on plus the torque n. What is the formula for the torque? The formula for the torque, as I know, this is R1 F1 plus R2 F2 plus and so on plus Rn Fn. What is the formula for the force? The formula इधर मैं लिख सकता हूं, since a torque is Rf. Now what is the formula for the force? The formula for the force is, क्या होता है force का formula? Ma. And what is A? A is R into alpha. Therefore, this force will be Mr alpha. Mr alpha. So what I can do is I can write this will be R1, M1, R1 alpha plus M2 R2 so this torque can be written as R1. F का place पे this will be M1 R1 alpha plus R2 F2 का place पे M2 R2 alpha plus and so on plus Rn Fn का place पे Mn Rn alpha. Therefore, this torque में I can take a alpha common. This will be M1. R1 into R1 is R1 का square plus M2 R2 का square plus and so on plus Mn Rn का square. Therefore, this torque will be alpha. This will be a summation from I equal to 1 to n of Mi Ri ka square. Now this Mi Ri ka square, this part, it is nothing but a moment of inertia I. Therefore, this torque will be I into alpha. This torque will be I into alpha. ठीक है? Now we have come to the last part. Hardly 5 minutes I need. I'm just making a full screen. You can all go through this. You can take the SS and you can just reply me once you are done. Okay, done. So we have come to the last part of this chapter. we have come to the last part of this chapter where we will be talking about conservation of angular momentum. So let's discuss about a conservation of angular momentum and its applications. Before I do this, you might have seen that, let us say that you are holding a very heavy object in one of your hand, right? अगर आपने कोई हैवी ऑब्जेक्ट को अपना एक हाथ में होल्ड किया है, देन बाय मिस्टेक क्या होता है, यू मे tilt to the one side unless you stretch your another hand. This is a principle of conservation of angular momentum. So what this principle of conservation of angular momentum says, or the law of conservation of angular momentum? Let's talk about this law of conservation of angular momentum. But we know that the external torque, this external torque, it is a dl by dt. When a torque is zero, then a dl by dt is zero. What is the meaning of a dl by dt zero? This L will be a constant. It means when therefore, when no external torque is acting, when no external torque is acting, total angular momentum remains conserved. When no external torque is acting, a total angular momentum remains conserved. It means L, it is equal to constant. Now what is L? L, it is equal to I into omega, that is constant. It means for the two system I1 omega 1, it is equal to I2 omega 2. There are n number of examples we have seen for this. You might have seen that ice skater or the ballet dancer, they can increase their angular velocity by folding their hands and stretch their legs close to the other leg. जब ये लोग डांस करता है तभी they can stand. Or up, you can take your own example that if you are standing and putting your hands unstretched, and if you are rotating in the circular path, you may fall down. And the moment you start stretching your hand, then you will not fall down. Right? Now the last part which has come about a rolling motion. A rolling motion. So whenever the body is rolling, then what is the formula for the kinetic energy of a rolling motion? So my dear student, the kinetic energy of a rolling motion is, it is half mv square, but this v, it is a velocity of a center of mass into 1 plus k ka square. What is k? A radius of gyration. Right? And what is r? R is nothing but the perpendicular distance. So for the rolling motion, ये formula कैसा आएगा? I'm just giving the trick. For the rolling motion, if I'm calculating the kinetic energy, it is the kinetic energy for the translational motion plus the kinetic energy for the rotational motion. What is the translational kinetic energy? The translational kinetic energy is half m velocity of a center of mass, and the kinetic energy of a rolling rotational motion is half I omega square. So with this, we have completed this entire chapter. I'm sorry, there is a 1 minute delay. I'll feel very happy if I can get some feedback in the chat box, right? Okay, thank you so much. Yes, now we will be solving a MCQs from the JEE and NEET exam. Okay. Yes, now wish you all the best. Thank you so much, everyone. Bye. Take care. God bless you. Bye. Okay. Thank you so much for your kind words. Bye.